let's start working with the ideas of quadratic word problems. So, guys, what I'm looking at doing here over the course of the next couple of days is we're going to work through quadratic word problems between today and tomorrow. Come Monday, we're going to work on the graphing of quadratics and finding the intersections of shaded regions. Next Tuesday, we will do a little bit of a modeling part. A lot of this blends in with the modeling. That'll give us review day next Wednesday, and we'll test out of quadratics next Thursday prior to our 4-day weekend. That way we don't have to stretch it over the 4-day weekend and forget about everything, because that's just bad. A week from today, we'll take our quadratic test. Okay? I think I already put it on the calendar too.
What?
You're probably like,
You hate when teachers do stuff? Fine.
Yes.
So, what I have found that since I'm going to be working, guys, I'm going to be working through a bunch of different sections in the book with all these different word problems and whatnot.
How would people know this?
I'm going to sit there. That's why I decided it was easier for me to just kind of snapshot these into the notebook file and just print them out. I don't normally run copies, especially nowadays since you have the Chromebook, but instead of having to open up, basically it works out to be 7 different sections of the book to get the word problems. Why not just make a quick little pack and just be done with it? So that's why we did this. Excuse me. So here's what we're going to do. What I want to work through today is basically the kind of the first page of these. Tomorrow we'll start talking a little bit more about what you can use with the calculator and going from there. My goal is to make sure that we have tomorrow be a couple of questions and a work day to finish them out. That way we can try and knock them all out tomorrow so you don't have to worry about them over the weekend, because I know you're not going to do them anyway. I know, I'm not a doofus, as much as we hate to believe that. So let's go through a couple of these together, try one on our own, and see what we come up with. You have made a rectangular stained glass window that is 2 foot by 4 foot. Sounds beautiful. You have 7 square feet of clear glass to create a border of uniform width around the window. What should the width of the border be? Why are you shaking your head? It doesn't seem good? Well, personally, I think stained glass windows are very, very nice. So, what I want to do is get an idea.
draw on the window.
So, do some work. Play on your phone, play on your computer. I mean, seriously. Might not be a bad idea. So, let's see here. 1 foot. There's 2 feet. Here's 4 feet. It is beswing. So we have this awesome stained glass window. Thank you. So there's your stained glass window. It's 2 foot by 4 foot. What's the square footage of that? 8. It's an 8 square foot stained glass window. With some pretty color, the sun shines in, it's gonna make a really awesome reflection on your pages of work. It's gonna look really sweet. Now, what's that? It's something. She's right next to Mona Lisa. Now, what this problem says is that you have 7 square feet of leftover clear glass to put a border around this. Okay? Now, what they're saying is that it wants to be of uniform width. That means the width all the way around has to be the ding, 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 ding. So, if I go ahead and draw my uniform width of border, and I call each, so I know that this width here is 2 feet, this is 4 feet, oh, that's inches. Now it's feet. Now, 2 feet by 4 feet, if this chunk here is uniform, and I don't know how much it is, what should I call it? X. So this is X here. This is an X here. X here. There's an X. Where's an X? X. Oh, I made that up. It's only now he had an X. Anyway, so now, what is now this width?
2 feet. No, 2x.
How much? It's 2 plus 2x. And how much is this width? 4 plus 2x. Now, I have this I have now a new area that I can find. 2 plus 2x by 4 plus 2x. Are we okay with that?
Did you get the 2x because like the line, like the dashed line is x?
Well, I'm just showing that it's still continuous, that it's the same, it's just showing the same width.
No, I'm just saying like when you got 4 plus 2x, because like the width right there is 4, and then
This x, I'm adding to the width in this part here. So there's 2 of them.
yeah, that's so it's like the dashed line that part's x.
Yeah.
Yeah.
I misunderstood where you're going with that. Now, how do I figure out what value of x to use? That border line has now been created, but I have a big chunk that I need to take out of it, don't I? What do I do? Yeah, what do you got?
I did 2 plus 2x times 4 plus 2x
Think about what we have here. I have it already, I think I have it pre-drawn in this too. I think it's kind of fun. I never did that on the window. I've done this problem before, never did it on the window. Think about what you have. I think it's kind of cool. It's a good idea. I should have done it on this window, but nah, that one's cooler. Think about what you have. The area of the border is going to be the area of the border and the window, and subtract out the area of the window, and that's kind of where you're going. Since you know that your border is how much? Is 7. We know that we are given that the area of the border is 7, is going to equal the area of the border and the window, which is our, excuse me, what was it? The 2x. Oh, no, not 2x, I'm sorry, it's 2 plus 2x, excuse me. Oh, I can write it like that, 2x plus 2. And then 2x plus 4.
Why is it 7 and not 15?
You're on the right track here because what do you have to subtract out?
You have to subtract the window.
And that's what you already did.
Oh, okay.
Okay, and that's perfect. Because what you're trying to do is you're trying to find the area of the border. You've got a whole chunk. You guys did area of shaded regions last year, didn't you? That's all this is. This is an area of shaded region problem with a quadratic. That's it. Now, when you walk through this one then, you're going to have, there's a couple of ways to set this one up. What do you think the easiest way to do this one is?
Distribute.
You can distribute, okay, or what else could you do? That's pretty sweet, actually. So, watch what I would do here to make everything easier to figure out what my value of x is going to be. If I put it to 15, then I have the quadratic equaling 15. Do you agree? Now, if I go through and FOIL this out, first of all, we're going to get 4x squared, 8x and a 4x is a 12x, plus an 8. Everybody okay with that? FOILing that out? And then I have a minus an 8. And then if I move the 7 over, I then set it equal to 0.
And then you solve for 0 using one of the thingies. That
Exactly. So what you have it equaling 15 is perfect, because you still would FOIL out all of your stuff, and then when you bring the 15 back over, it's still going to be 4x squared plus 12x
Minus 7.
plus 12x, yeah, and then minus 7. And that's exactly what you're going to wind up with. This is an area of shaded region problem that you guys did in geometry last year without the mixture of a quadratic. That's it. That's the only difference here. Okay, that's the only difference. So now you have a bunch of different methods to choose from. If you go through and think about the different methods that we have to solve this problem, one of them is factoring. That was the first one we did. So if I look at this one, what's 4 times negative 7?
28.
So we ask ourselves real fast, what times what is negative 28 that I can add together to get a positive 12? 14 and negative 2.
Dang it, how do you do that?
So when I start looking at it, this actually works out quicker to go right to a factoring problem. So if I do that, we get 4x squared minus 2x plus 14x minus 7. Do you guys remember when we did factor by grouping? If you have a positive and negative middle term, it's generally easier on your brain if you put the negative one before the positive one. That way you don't have to worry about trying to factor out a negative later on. It's just a little trick that I usually do. Now you go GCF. 2x, we get a 2x minus 1. Take out a 7, we have a 2x minus 1. Are these two terms the same? Yeah. Those two are the same. We write it down.
If it's not the same, you just...
You probably did something wrong there. If you're doing this correctly, Emma, you should get those two terms in the parentheses to be the same, because that's the goal.
Yeah.
Because what you're doing is you're GCFing it twice. What are your two zeros?
Then you know
Negative
that
7 halves and
that you dumb goof.
which one of those is the right answer? 1/2. You should have a 1/2 inch border all the way around. That's it. Hey! How are you?
I'm good, how are you?
You're supposed to say groovy.
Oh, I'm groovy.
Whatever. So that's all it is. Hey, have a great day.
Hey, you too!
What? This is a great thing that you're in here today, then, right? Okay. Let's try another one.
Wait, how did you get 2x plus 2 times 2x?
Here. Go back to the border of the original window frame was 2x4. We had to add in a uniform value around it, and it's x all the way around. because it's the same width. I'm just showing it's the same width all the way around. That's all I was doing. So going from here to here now is 4 plus 2x. Going from here to here is 2 plus 2x. That's all it is. Because you're taking a picture and you're putting a frame around it. That frame is the same width on both sides. That's all I did.
That part confuses me.
Okay, that's where it came from.
So, like, but what do you do with the number 7 when you're drawing? You don't use it?
No, because your question was, what should the width of the border be? Well, you have 7 square feet of the border, and you go through it. So that's all it's going.
So,
You were trying to, bless you, you were trying to find the area of a shaded region to make it equal to 7. That's basically what it was.
I just struggling
The other style I want to show you today is you flip over to number 99.
I just hate words on so much.
I want to flip over to 99. I think I had that one next. A shoe store sells 200 pairs of basketball shoes each month when it charges $60 per pair. For each $1 increase in price, about 2 pairs per month are sold. Two fewer pairs per month are sold. How much per pair should the shoe store charge to maximize monthly revenue? Yeah, remember, the S's are so hard for me to say. What this question is doing is, well, remember, this book was made in, oh geez, what year was this one? I want to say this was, this one's dated 04, but Lord knows it's not 04. So, what do we do here? We have, you're selling 200 pairs of shoes at $60 per pair. For each $1 increase in price, 2 fewer are sold. So you have 2 things. You have cost and sales. In your cost, how much is each pair of shoes costing you? 60. So $60. And when you sell them at $60, how much do you sell? 200. For each dollar increase in price, so I'm adding $1 per, for each increase in $1.
But it's oh, I thought this said 1% increase.
So I put a 1 there just so that if I increase it by 2, it'd be 2 times 1, so it'd be $62, and then so on. For each $1 increase in price, what happens to my sales figure? 2 fewer, so it'd be minus 2x. Find the maximum. What do you do? What form is this written in?
This is going to get something x squared plus something x.
You don't need to think of it that difficult. It's intercept form. This is an intercept form of an equation for cost and sales. It's a very, very easy one to work with because you know that you have zeros. You have zeros at negative 60.
And negative 200.
Whoa. Whoa.
100.
100.
Oh.
Okay?
Wait, why? Oh.
Now, if I FOILed this out, would your A value be positive or negative? Be negative. And plus, it also asked you for a maximum, didn't it? Now, think about where a maximum occurs. If you know your zeros, doesn't the maximum occur up top? Thank you.
Up top.
The maximum occurs at the halfway point of the zeros. Because remember, aren't zeros symmetric twins? They're on the same horizontal line. Zeros are symmetric twins when you're dealing with quadratics. Halfway between them is your axis of symmetry. The axis of symmetry is the x value of your
Vertex.
which allows you to find your
Y.
which is your maximum.
So 20 is your axis of
Oh my
symmetry.
God.
So what's negative 60 plus 100? 40. It actually would be other way around. There you go. Now I can see it's 40 to me. 40 to you now. So the halfway point here, well, if you add 100 to negative 60, you get negative 40. I'm sorry, pardon. 40. Half of 40 is
20.
20. So at x equals 20 is the halfway point between here and here, which means,
Plug that into X, then you distribute the solve.
oops, let's move this all the way down.
You can like lock it all.
I know. I don't know why this is being silly. Which means this ordered pair here is going to be 20, comma, something. So that tells me if my x value is 20, what should I sell them at? 80. My x value is 20, so that means I sell them at $80. And how many will I sell?
That's pretty good.
Well, 2 times 20 is 40, and I will sell 160 of them. Sell them for $80, and I will sell 160. That's how I maximize my profit. Okay?
Oh my God. I'm so confused.
How?
This like makes no sense.
Yeah.
Go back to graphing.
No, this is like how like
No,
at the
I
beginning where I didn't
I understand all of it, I just think it's hard to like come up with the, like the.
You guys are gonna have to work through these. It's gonna suck. You're gonna have to work through them. You're gonna have to work through them.
The hard
Okay.
part is just, like, I understand all of it, I just
Yeah, we will be doing this for homework.
like, when I do it with you, it makes so much sense, but like, it's just like, given the problem, it's hard to like come up with the constraints or whatever you call them.
Yeah. Try that one just like that. Electronics stores considering placing a new model of digital camera. At the current price of $680, the store sells 70 cameras a month. Sales data from other stores indicate that for each $20 decrease in price, 5 more cameras per month will be sold. At how much should the manager charge for cameras to maximize monthly revenue, and what will the monthly revenue be? So remember, when we deal with problems that sound like this, you have 2 things, cost and sales. And it's a quadratic, because you're maximizing it. Okay. What is your cost? The current cost. Yes, ma'am.
I think I did it.
All right.
Is it
What- what-
680 minus 20x and then 70
What's your cost?
680.
680. How many do you sell at 680?
20. What? 17.
For every $20 you decrease in price, so where does that go to? Cost or sales?
Cost.
So I'm subtracting $20 per. Every time I subtract 20 bucks. So one time I subtract 20 bucks, it's 20 bucks. Second time I subtract 20 bucks, it's 40, and so on. That's your multiple there. When I subtract 20 bucks, how much does the sales increase?
5.
For every one of these I subtract, I add one of those by 5. So if I subtract it twice, I'm adding 10. If I subtract it by $40, I'm adding $10 in sales, and so on and so forth. So this format is what we call intercept form. When you have your two terms set equal to 0, it is the fastest, easiest way to solve the problems is to get your zeros on the x-axis. Figure out where they cross each other. Okay? Cost sales problems are always the same. Find your zeros, midpoint, substitute in, and you're done.
Is that at 34 negative 14?
So
Is that what you got?
what was it? 34 and negative 14?
Yep.
Okay. So here's negative 14, and here's 34. What's 34 plus negative 14?
20, no.
20.
Yeah, 20.
What's half of 20?
10.
10.
So where's your axis of symmetry? It's at 10.
And then.
So that means my vertex is going to be at, x is going to have to equal 10. And then, so I need to, I will sell
480.
for 400, if I sell them for $480, I sell them at $480, how many will I sell? 120. I will sell 120 units at $480. That's the maximum sales I would get. That's how these things work. A lot of these, when you have, bless you, when you walk through some of these here, a lot of times it's a matter of, are they setting me up in terms of a 0? Are they setting me up in terms of finding a maximum or minimum using my calculator? When you see them as cost sales styles, always go with that intercept form. It's the easiest way to do it. Okay? You could have foiled this out. You could have put this all in the calculator. You could have done quadratic formula and gotten all those values. Actually, quadratic value would have gotten you your zeros, but then you would still have to find your opposite of the over 2a and all that other stuff. You don't need to do all that extra work sometimes. You start intercept form, work out of it because it's fast. Now, a couple of hints I will show you.
Wait, Mr. Murphy, what was the answer to the 99? Was it 80 and 160?
I think that's what we got, right? Oops. Yes. So, real fast, when I go back and I look at, and give you guys a couple of hints here. The quilting one, number 90, is basically the exact same problem as the stained glass window. Okay? 91 is kind of a little bit step past it. It might be a little bit trickier. But think of the idea of, think of area of shaded regions, okay? 97 is also very similar to the border problem. 98, it's intercept form. Actually, 98 is probably the easiest one on there for that. And then 101 is a calculator problem. I want you to try that first page there. 101 is a calculator problem.
So 90, 91.
Yeah, just that first page. Try to do that first page.
The whole first.
The front back. There's what, 5? Okay. Try and work through those. I did the 2 sales ones for you. I will recommend this for number 101. Draw a picture of what you think it is. Draw a picture, and then you'll be able to work yourself through it. Tomorrow we will talk more about velocity. We'll talk about why you can't go around a curve at 110 miles an hour and you can only go through at 40, because there's a formula for that. We'll talk about what goes up must come down, and what it means to have items that are launched versus items that are dropped. Yes.
That like mentioned like gradual.
What's
Is
that?
that the one that like basically a left turn?
We just read Act 3. We watch Act 3. No.